Hello everyone, am I audible? Okay, okay, yeah. Actually, I am the course team member who is supposed to take the live interaction session. So, I welcome you all for the first live interaction session of the course Renewable Energy Engineering, Wind, Solar, and Biomass Energy System. So yeah, we will just start within the next 3 or 4 minutes before the let us give some time for others to join, and we will start within the next 2 3 minutes. Uh, yeah, sure. I guess we can start right now. Yeah. So, good evening, everyone. So, let me introduce myself first before we begin the session for today. I'm Pratyumnan. I'm currently a PhD scholar at the Indian Institute of Technology, Guwahati. So, I will be the course team member who will be concerned for conducting the live interaction classes for this particular course on renewable energy engineering, biomass, wind, and solar energy systems. So yeah, so I welcome you all for the course, and here I am planning for this week to actually conduct this live interaction session in two sessions. Like the very first session will be a beginning, like a recap of what the course content was there for the very first week, which was covered by Professor Anandalakshmi ma'am in her course. So after that we conclude, that will be just for like 5 to 10 or 10 to 15 minutes at the max, and after which we will proceed to the real problem solving session, where I have actually 2 to 3 problems, quite bigger ones to be honest, to really solve, which are of almost of the same way as it was previously done in the course lecture also. But yes, uh, I believe that doing the same kind of model once again will be actually helpful for many, because it's the calculations are quite tedious as such. So yes, let me just share my screen and then we will start. Can anyone just confirm me whether you are able to see my screen, like the PPT, the PowerPoint? Oh, okay, yeah, thank you. And so yeah, in order to just avoid other disturbances, so I just prefer like everybody just mute your mic, because sometimes there will be some internet connectivity issues or some other noise which might be interrupting the voice. And before I begin, I would like to also inform everyone that the session is getting recorded. So once the session gets over, the recording will be shared by the NPTEL team to everybody whoever has registered for this course, either through the email or some other mostly through your emails. You will get the link for the recording, or in my YouTube channel also it will be available, so you can always go and rewatch, or in case if you have any doubt, you can always uh, check the video whenever required. So yeah, so the course is Renewable Energy Engineering, Solar, Wind and Biomass Energy System. So this course is offered by Indian Institute of Technology Guwahati under NPTEL program. The course instructors are Professor Vaibhav Vishant Gaud and Professor Anand Lakshmi ma'am, and myself, I am Pratyumnan, who is basically the teaching assistant who is responsible for this live interaction course. So the very first week recap. So there were totally 4 lectures which was conducted. The first one was about the basics. Then we move on to the collectors, and then the last 2 videos was purely based on the calculations of different kinds of solar angles, day length, and various other parameters which are very important when we move ahead in the course. So the very first question I want to ask is renewable energy. As such, the name itself has its own content. Energy. Everybody require energy to do their work and to harness power and so many other things for which we require energy. And most of the vehicles that we use today, I hope everybody uses at least have cars and scooters at their home. So all those things uses petroleum and other fossil fuels. Burning of these fossil fuels, petroleum is available at a cheaper rate and is easily available, but when you think in the form of, in the perspective of how it is formed, if you see ocean and marine organisms, when they die and they get deep buried inside the soil, and then when these organisms and other plants undergo deep, when they get buried under high temperature and pressure, they get decomposed, and that results in the formation of this trapped oil and the fossil fuel oils, which you actually take it out and then use it in different vehicle systems. But you see the time scale, 300 to 400 million years for the formation of the system. So which is approximately to collect your fossil fuels somewhere around 300 to 400 million years ago, the organisms would have died, and that is what you are taking today as a fossil fuel. So the time process for the formation of the fossil fuel is so huge that, as everybody is aware, that we are actually undergoing a depletion of the fossil fuel. We will soon run out of coal, petroleum and all other products within, if the estimate, if I am not wrong about the estimate, 2050 we will probably run out of, and there will be a huge energy crisis. So for this, in order to prevent the energy crisis from happening, and To preserve what we have to shift, or we have to think it in an alternative approach. That is where the concept of renewable energy comes in. What is the meaning of the word renewable? Can anybody just unmute and tell me? Yeah, so something that you can renew it again and again, something that is basically present, in abundance. There is no limit for its use. You can continuously keep using it for many years, but still it doesn't get exhaust. So there are many different types of renewable energy. You have geothermal, you have wind power, and so many things. But one of the most common and the most, you know, everyday what we see is the sun. Every morning when you wake up, you can see sun, and it sets only in the evening. So there is so much abundant amount of the sun, the energy that you can harness from the sun. The sun itself is a huge solar power system. The thing is, India as such is a very blessed country because we lie near to the equator. We are situated near to the equator. So the amount of the amount of energy that you can capture from such this thing is like we are truly blessed. That is not probably the case with other nations, other European nations or American nations during their winter times, because there they do not really get sunlight during that particular month period of time. Whereas India is not like that. We have for all the seasons everywhere except for a few, everywhere we have sunlight all throughout the day. So we as such is a blessed country who should actually harness this, and there have been lot of research focused on using solar power these days to basically maximize the the energy that we get from the sun. So the sun as such, you can harness its energy in two forms. Oh, sorry. One is through direct heating and another one is through solar PV. So this course specifically does not concerned with the use of solar PV. We just go for direct heating. But solar PV as such has a lot of its own limitation. If you see the photovoltaic cells, the cost is huge. You require lots of even for a small building, it requires thousands of rupees to install for your home, which has energy, which might not have an energy consumption as huge as a building. So you can really think of the magnitude amount of the investment that you have to invest for installing a solar PV panel for bigger commercial buildings. So that much amount of money is required, and even after spending that much amount of money, does anybody have any idea on what could be the efficiency of the solar cells or the photovoltaic cells that are used in the recent time, I mean today in the contemporary times? Yeah, it's almost around 36% to 46 percentage. So that is not something that is very feasible, because you spend so much amount of money, but at the end what you get is only 46 percentage of the uh, you know sunlight. So for that we have to like research there are a lot of research going on with using this kind of solar of photovoltaics, about the design, the architecture, the materials, and etc. So anyway, this solar PV is something of not for today's topic of interest, because this has been specifically limited in the course itself, that we will only focus on the concept of direct heating, like how do you actually collect the sunlight that falls on the surface and use that sunlight to store the energy. So this solar energy is also kind of you can avail it indirectly in biomass as well as that of the wind energy. So the sun gives the energy for photosynthesis. So the photosynthesis in plants happens within the presence of sunlight. The sunlight is what is responsible for the breakage of the water molecules into H2 and O2, which then combines to form the carbohydrates, and then these biomass again the plants are which the plants utilize, they grow, and then people use it, and then the waste is what we call it as biomass. So even in biomass the solar energy is indirectly used, and that is what is even he explained, even clearly explained in the lecture. So in the photosynthesis process, the sunlight is required. The sunlight is responsible for breakage of the molecules of the water, especially the H2O gets converted to H2 and O through the process of photolysis, and that is basically taken up for the formation of the carbohydrate, which is available in the form of fruits and other kind of you know parts which is edible for us. And this, once the plant dies, that is what we get it as a biomass. And wind energy, the movement of the the air from the sea to land and from the land to sea during the morning and the evening time, this concept of sea breeze and land breeze, that, and then the movement of the wind blowing from the north part of the country to the south part of the country, and from the south to the north part of the country, that movement of the wind could also be used for harnessing the energy. So the solar energy forms the basis. With the solar energy, we go for is indirectly involved in biomass and wind. So that's how the lecture has been organized. First, we basically concentrate on solar. So the sun. So the renewable energy, as such, as I told, is abundance. It is of cheap cost. I mean, as such, because sun as such is available, so you do not have to like spend money, unlike in case of fossil fuel, where you have to actually dug deep inside the soil to remove. And then it is environmental friendly, it does not emit any kind of pollution, and it can be used again and again. Again, that is what is the concept of, somebody said replenish, renewable, again and again you can use. There is no limit for its sun. I mean, every day the sun is going to come throughout the humanity exists. I mean, throughout the earth is still going to be there and the sun is going to be there. You will be receiving these solar energy to the solar energy will be available for us. So next we move on to the concept of, again, in order for this direct heating, there are a lot of different ways to collect and measure the amount of energy that falls on the system. Like you have the pyranometer, pyrheliometer, and there are different kind of equipments which have been detailedly discussed in the lecture. We move on to solar angles. So this is probably your horizontal surface, I hope everybody can see, and this is your tilted surface. So the sun, when it falls on the tilted surface. But if you have to do many calculation, you actually need to know the different terminologies. So here I am going to again tell the definition for each of these angles, because that is very crucial. The definition is what helps you to understand the problems that we are going to solve in the next few slides. So the latitude of the location. So the latitude of the location is basically the place where you stay. So it is the location, it's the point, it's connecting the center of the earth to your point, and that line's projection on the horizontal surface is called as a latitude of location. Declination. Can anybody say what is angle of declination or declination angle? Okay, declination angle is the line joining the center of the earth and the sun and its projection on the equatorial plane. So you have sun, you have earth, and then the line joining the centers of the sun and the earth, and that's projection on the equator is what is called as declination angle. And you have the hour angle, which is basically an angular measure of the time. You have the solar altitude angle, which is the angle between the sun rays direction and the projection of the sun's ray on the horizontal plane on the earth's surface. That is, this is the sun rays direction. This projection of it on the horizontal surface is what is called as solar altitude angle, that is this alpha A. You have these zenith angles. Zenith angle is very easy. It is angle between the sun's rays and then the normal to the horizontal surface. So this is the horizontal surface that you have. The normal to this is the zenith angle, and then this is the sun. So the angle between this sun and the zenith is called as uh, zenith angle. This normal and then the sun. The angle formed between the two is called zenith angle. Then you have the surface azimuthal angle. The definition, I'll just read the definition. Angle made in the horizontal surface between the line due south, this one, and its projection on the normal to the horizontal surface. So the projection of it onto the horizontal surface and the line due. So this angle is called as solar azimuthal angle. Oh, sorry, surface azimuthal angle. Solar azimuthal angle is the this one. Oh, sorry. Just a second. Oh, sorry. Okay, okay. So surface azimuthal angle is the angle made in the horizontal direction and the line due south. So this angle is called as surface azimuthal angle, and this angle is called as solar azimuthal angle. Slope is basically the tilt of your surface. Like you always keep your surface tilted. It's not like a horizontal surface. You always keep your surface tilted so that you can optimize the amount of energy. You need to actually tilt the surface so as to get the optimum amount of the solar energy every day. Throughout the day, you have to like get the optimum amount of energy for your consumption to be proper. So for that, you need to tilt the surface. So that tilt is basically given by beta. Angle of incidence is this is your tilted surface, the normal to that, and then the sunbeam's direction. The angle between the both is called as angle of incidence. So once you have the clear idea on this, we can actually move on to this problem solving. So does anybody have any kind of question within the last two slides? Yeah. Oh yeah, that actually we will go like as we go through the problem, you will be able to understand how to calculate our angle. So the thing is it are you guys okay with the pace, and then what do you have any doubt in what I have just told, or do you want to actually like have any questions? Okay, okay, yeah, yeah, yeah. So yes, this is just the recap. So here I just wanted to emphasize how renewable energy is important for us, because this is what will take over the research direction in the next few years to come. So we need to focus on renewable energy because we do not have time as well as the amount of fossil fuel left for us to continue for a long generation, for generations to come up. I'm not sure. Probably in the next generation that is going to come, we do not know whether we have fossil fuel left for them. So it is a high time that we prioritize focus on renewable energy like solar or wind or biomass or any other kind of solar energy, so that we can sustain the energy for the next generation. And so now we actually move on to the problem solving session. So in this session, I hope everybody has a notebook and a calculator with them, because it's a huge calculations. There are so many different angles that we need to calculate in order to finally end up with the monthly average global radiation, the diffusive radiation, hourly average, daily average, hourly average, though the global radiation and the diffusive radiation. So we need to actually follow every single thing step by step so that we can actually end up there. So I just want to see, like, I hope everybody has a notebook and a calculator with them. Yeah, so here, will it be okay if I just minimize my, if I don't show it in my PowerPoint presentation mode and in the normal mode? just do that because I have to show the calculator. I have actually given everything here in the form of I have solved it previously and then I have pasted those pictures here, but still we want to solve it every step by step. That is actually the motive of this session. So I guess it is better I will, come out of the PowerPoint mode. It's still visible, right? Okay, yeah, sure, yeah. So let's first read the first question. A flat plate collector is installed at an angle 45 degree from the ground pointing south. Calculate the solar angles, day length, air mass on the following days at 16 hours local apparent time for New Delhi on August 16th. Consider the average sunshine hours to be 9.2 hours. So here we have to calculate all the solar angles. So I have given the question in such a way that we have to calculate all the angles. And this is a kind of question similarly what is solved in the video, but you actually require to put a pen and a paper and then solve every single question step by step, because without that this, well, probably for exam you may not be getting such big questions, but if you have to actually design a flat plate collector, which we will see as we go through the course in the future of the course, probably in the week 2 and week 3 lectures we will be discussing that in detail, but this will be very essential. So I just request all of you to use a pen and a paper and really solve, and in case if you have any doubt at any point of time, kindly interrupt because this is very important. So here we have a flat plate collector and that is installed at an angle 45 degrees from the ground. So if you consider this as a ground, the flat plate is basically 45 degrees from the ground. So this angle, if you see, like if you see this angle, the angle between my hand and the pen, that is 45 degrees. If you see here also I can show. This beta, this is the horizontal surface and this is the tilted surface. You can see my cursor, right? Okay. Okay, yeah, thanks. So that angle is called as beta. And you are supposed to calculate the solar angles, day length, air mass, and all the other parameters on the day at 16 hours for New Delhi on August 16th. And the average sunshine hours we have assumed to be 6.2. So for this one, let's just, so we have been asked all the solar angles. We have been just given the location New Delhi. So what do you think? So let's just start from here. What do you think could be the very first thing that we should know before actually we move forward for the problem? Anybody? Yeah. So New Delhi is given. So it's our duty to actually, like, I mean, in the exam or in the kind of assignments that you do, you will be given the latitude and longitude, but here I have not given. So for New Delhi, the latitude is 28.64 degree north and longitude is 77.21 east. And I hope everybody knows how to convert here if it is given in the case, like, let's say it's in minutes and not in degree angles. Suppose, let's say, let me use my calculator. Okay, fine. So if suppose, let's say this, instead of being as 28.64 degrees as such, let's just say that they gave you 26 degree and 64, or let's say 45 minutes, then in that case you have to divide that 45 divided by 60. So 0.75, and then you need to add that 28 plus 0.75. 28.75. Like here I have just directly given it in degrees, but you cannot actually expect that to be there like that in the exam or in the assignments that you solve. sometimes they might give you in degrees. So sometimes they might give you in degrees, and sometimes they might give you in minutes. So you need to be very kind of careful with that, because that will actually alter your answers everywhere. So let's just, before actually solving, let me just give you one question. um the latitude of a location is 28 degrees 17 seconds. So just, can anybody tell me what will be the degrees, like in the degree form, because this is 28 degrees 17 seconds. I want it in degrees. Yes, anybody? Nah, but that is, you are saying that 360 is basically like on, how did you say like 360? Can I just know? Yeah, so you have already 28 degrees. So here you just need to bother only about that 17 seconds. So this thing would be, if I am not wrong, according to me, the answer would be 28.2833. Is it what everybody are getting? I mean, did everybody solve this one? And what is your answer? Can I know? Okay, that is for the seconds, right? Like, what is in total, like final form? Like, it's 20 degrees 17 seconds. So I want the whole thing. So it would be 28 degrees plus that 0.28. So it will be like 28 degrees 283 degrees, like 28.283 degrees. So yeah, so that is something where you guys need to be careful, because sometimes they might twist, because it's not necessary that actually, honestly, if you Google anywhere and check what is the latitude of a location, it will be given in 28 degrees some 17 seconds or 18 seconds, and it will be like that seconds will be denoted by a, what do you say, asterisk mark, like high, what do you say, the upper comma. So let's just start with the problem. So this is the, so latitude for New Delhi is 28.64 north, 64 degree north, and longitude is 77.21 degree east. So here we need to actually calculate first the solar angle. So first we need to calculate, let's say we need to calculate the angle of incidence. So angle of incidence as such is basically a large, what do you say, is basically a function of many different angles. Like if you calculate those angles, then only you can calculate angle of incidence. So here if you see, I have written a expression that, I mean, as an expression that angle of incidence theta is a function of phi, delta, beta, gamma, omega. Can anybody just tell me what are these angles? Because you know, sometimes you need to be careful with the angles also, like the notations. Okay, so your phi is the latitude, that is 28.64 degrees. Your delta is the declination angle, as I have stated here. Your beta is the slope, that is the angle at which the flat plate collector is installed. Your gamma is the your gamma is surface azimuthal angle. That is, how much does the flat plate surface normal is making with the south direction. And omega is your hour angle. So the formula for calculating the angle of incidence is this way, that is cos theta equals to sine of the latitude times sine of the declination cos of the slope plus you have cos of declination, cos gamma, cos omega, cos of the hour angle, and sine beta, that is sine of the slope. And then you have again the cos term, cos of the latitude plus cos of the declination, cos of the hour angle, cos of the slope minus sine of the declination angle, cos gamma sine beta plus cos delta sine gamma sine omega and sine beta. It's a huge expression. So here we do not have any idea about what is, except for theta, which is the latitude of the location. We have to calculate delta, beta, gamma and omega. So yeah, let's start calculating that. So first, okay, now I'll go to my PowerPoint. Oh, but calculate. Okay, I'll just keep rotating. So declination angle formula is 23.45 into sine 360, sine of 360 into 284 plus n divided by 365. This 365, even in case of a leap year, it will remain as 365. It's just that the value of n will differ. So August 16th, can anybody tell me what is the August 16th date would be? Like the n value for August 16th. Yes. So anybody has, like, August 16th is the date. 220? Yeah, because Jan has 31, and I'll just show the calculation here. Since it's not mentioned whether it's a leap year or it's a normal year, we can add 28 for February. But if it is mentioned, then you need to add 29, and then 31 for March, and then you have April with 30, May will come with 31, June will be 30, July will be 31, August will be again 31. Oh, sorry. Sorry. Yeah, 16. Sorry. 228. Here you need to also calculate the August 16th date on which you are going to calculate. So that is important. Then, so here you need to actually put the pen and paper and then just let me know. See, you know the formula now. So you just calculate with the n as 228 and let me know what the answer you get. Meanwhile, I'll also show my calculation here in the virtual calculator. Has anybody calculated delta? I guess as I see there are others also who have joined the meeting. So for those people who actually missed the the very few parts, it's just that we gave a few very brief recap on what is renewable energy or how renewable energy is important, and we actually went through the definition of solar angles and other angles because those are very critical. And then now we actually started solving the problem. It's just that we are very you know starting to solve the problem. So anybody came up with the value of delta? Okay. So n is 228. So if you substitute 228 here, it's 284 plus 228, 360 into 365 into 23.45. So let's just calculate that here. So 284 plus 228, that is 512 into 360 divided by 365, and that is 504.986. I guess, I hope you can also see here, it is 504.986. Now, so sine of this angle we have to calculate, that is 0.573 into 23.45, 13.4549, we took 13.4. But here I want to know what is the sign. Is it plus or minus, or is there any sign convention as such is required for declination angle? Anybody? Has everybody calculated the angle of declination? Can anybody tell me what results they got? I mean, in case if you got some other results, then we need to really check what could be the issue. Okay, so this August 16th, as such, the value lies between your June 21 and September 21 equinox. So that value is a positive value. If you remember, it's plus 23.45 at on June 21st, and it becomes minus 23.45 on September 21st. So since August lies between both, it should be obviously a positive value. Now again, another one thing is your gamma value. So declination value, I hope everybody got. Okay, then gamma, what is gamma? It's your surface azimuthal angle. That is what your surface makes, the normal of your surface, the angle that the surface normal, that the surface, the project, you take the normal of your surface, project it in the horizontal plane, the angle between that and then the angle between the south line is the surface azimuthal angle. So here the flat plate collector is already pointing south. So since the flat plate collector is already pointing south, so the angle between the normal of the tilted surface, its projection on the horizontal plane, and then the line that is pointing due south, so that will be 0. That is what is written here. Gamma will be 0. So we have now 2 out of the function which we said incident angle of incident or incident angle, that is, which is we consider it as a function of phi, that is latitude. Then you have your beta slope, which is already given. Latitude we came to know as 20.8.64. Delta we now calculated your declination angle, that is 13.45 plus 13.45. And then you have your gamma now. Yes. Hello. Okay. Gamma is 0, which is basically the, the surface azimuthal angle. Now what only we have is the hour angle. So how do we calculate the hour angle? So the formula is given here. Formula is solar time minus 12 into 15 degrees. Now can anybody unmute and tell me why it is 15? Why do we multiply this with 15? What does that 15 signifies? So how did you calculate that 15? Like, can you just tell me, like, how did you get that 15? Yes, it is the angle of 1 hour, but how exactly did you get that 15? I guess the people who, like, I mean, I could hear some disturbances, like other kind of, like, I guess somebody's right there somewhere, so they can actually like mute. Yeah, 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 yeah. Okay, you mean this one? Okay, 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 okay. You mean this one? Ah, okay, yeah, sure. You want to note it down? Okay, like you can note it down, but I guess this is there already in the, in the lecture. Okay, yeah, yeah, yeah. Oh, it's done? Okay, okay. Okay, somebody, I was asking why it is 15. Can somebody tell me why it is 15? I mean, yes, one person told it's the angle for 1 hour, but how did you get that 1 hour? Like, how did you say it's 15? So it's the earth. So you have the sun and you have the earth. Earth rotates around the sun. Sorry, yeah, earth rotates. So it takes almost, earth rotates about its own axis and revolves around the sun. So for its one revolution it will take 365 days and it rotates on its own axis. So that will be like 360 degree, and for one entire 360 degree to complete it will take 24 hours. We have 24 hours in a day and it takes 360 degree to rotate. So 360 divided by 24, that is 15. 360 divided by 24, 15 degrees. So that is exactly what he mentioned, the angle for 1 hour. So yeah, this is the hour angle formula, that is solar time minus 12 into 15. So your solar time here, which is same as the LAT, the local apparent time, 16 hours minus 12, that is 4 into 15 is 60 degrees. So that 16 hours, even in many places it is written 1600. So what that actually means is it's your 4 in the afternoon. 4 p.m. in the afternoon is mentioned as 16 hours. Like when you write it from 1 to 24, you write it as 16 hours, and that two dots which you place will not be there. So 1600 hours is nothing but your 4 p.m. So 16 minus 12 into 15 is 60 degrees. So here I have said that the sign convention, according to the sign convention, the value is minus 60 degrees. So in the afternoon, in the morning hours, it is positive. In the evening hours, it is negative. So you have to keep this very carefully, because in case this, because a minus and a positive sign will interfere a lot in other calculations. So here it is minus 60, so which is very important to notify, because that sign convention will differ, because cos of because here you almost you have at many places cos. So cos of a negative angle will be cos of that angle, like cos of minus 60 if you see will be 0.5, same as cos 60, but that is not the case with sine. In sine it will be changing. Suppose for example do we have sine omega here, sine omega, hopefully we, yeah, here we have. So this value will completely change, and if this changes, this will entirely change. So the sign convention is very important. In case of declination angle, since the August 16th date lies between your June 21st and September 21st, that is positive, and in our angle, since the time is in the afternoon, it is minus 60 degrees. So minus for afternoon and plus for morning. So I hope the person who asked me how to calculate the hour angle would have been, it would be clear for them now. Is the person, is that is that person still there? I'm sorry, I don't know your name, but you were asking how to calculate hour angle. Okay, yeah. Now, beta is 45, that is the angle of inclination. Now, everybody, let us calculate. This calculation is quite tedious calculation, but we are supposed to do. You just calculate and let me know. I'll just within 1 or 2 minutes I'll just start this thing again, because it's quite big one, so you need to put all the values properly and calculate. So theta, angle of incidence, is critical. It's a tedious formula. So meanwhile, in case if you have any other doubt or this thing, because we will be discussing within 1 minute, so if you have any other doubts related to what we have discussed, you can always question. Yeah, exactly. Oh yeah, okay. So see, you understood why it is 60, right? Ah, so the sign convention matters. So for the morning half, the sign convention is positive, whereas in the afternoon half, the sign convention is negative. So that is why it's minus. If you see, even in the lecture, Professor Anandalakshmi ma'am has told, over there she took an example of 10 a.m. So if you take that, let me just use my, I guess, calculator itself, virtual calculator, and then let's see. So it's 10 hours in the morning. So 10 minus 12 is minus 2. That into 15 should be minus 30 degrees, honestly. But she, over there, she wrote it as plus 30 degrees. The reason why ma'am wrote that was because 10 hours is 10 hours in the morning. So at that time, the sign convention is positive. Here, since hours is 4, the sign convention is negative. So the sign convention is what is that, minus or plus. I hope it's clear now, or do you have any other like queries? Okay, yeah. So yeah, let's just start. Yeah. Hmm. Okay, today's interaction class. You should have received the emails, because I am also part of this course. So I also have received the emails regarding this. Or you can do one thing, you can always go to your SWAYAM portal, NPTEL SWAYAM portal, and from there you can, if you log in, you will get. Okay, yeah. Oh, okay. Okay. Then in that case, I guess I need to. Should I need to like re-explain something, because you haven't seen the videos? I guess it's fine, right? Hmm. Okay. So okay, then I'll just go with this pace, because we have quite a lot of slides also to complete within the next 1 hour. Okay, we will see. So yeah, this is minus 60 degrees. Now let's go to calculating the angle of incidence. So here I am not going to really say how do you calculate, because this is full of just substituting the values, but I'll just say hints where you are supposed to be extremely very careful. First is this minus. As I said, cos of minus 60 and cos of plus 60 does not make any difference. I'll just show that as well. I mean, this is very trivial, but still minus 60 cos is 0.5. The same, cos of plus 60 and cos of minus 60 is the same value, but if you see here again, that is not the case with your sine omega. It will be here sine of minus 60. So sine of minus 60 again sine of is 0.866 root 3 by 2, whereas if it is minus is minus 0.866. So this is where you need to be extremely very careful, because these are some kind of places where inadvertently, like, we may overlook it, so that might go against us, so we need to be careful there. And yeah, so here our phi is 28.64, our declination angle is 13.45, our beta, that is the slope of the flat plate collector, is 45. The same thing, cos 45, cos 0, and cos minus 60, sin 45. Here again the same thing. Here this value, because it is sine gamma, sine 0 of 0 is 0, so this entire expression will get neglected. That's the reason I have written as 0. So if you calculate all these things, you will get cos theta as 0.478, which comes out around, theta will come out around 61.41 degrees. So I hope if somebody would have solved, they would have got that value. And yeah, I hope, because I hope that calculations are not wrong. Has anybody calculated? Okay, so let's move on, because we have to complete. So our angles at sunrise and sunset. So here when we actually put these formulas, omega s is equal to cos inverse of minus tan phi tan delta, and omega at sunset, SD represents sunset, that is cos inverse minus tan phi minus beta tan delta. So these two expressions are obtained after a kind of what you call assumption that your sun rays are parallel to the horizontal surface. So the sun rays, that this is your surface, horizontal surface, and then the sun rays are falling. These sun rays are parallel to the horizontal surface. That is same at the sunrise as well as that of the sunset. That's how these two formulas comes up. Omega s is cos inverse minus tan phi, and omega st. So here your omega will be, if you substitute minus tan 28.64 in and tan 13.45, if you just multiply and take cos inverse in degrees, then your omega will be plus minus 97.5. Your omega st is phi minus beta, that is 28.64 minus 45. So tan of negative is negative, negative positive, so tan 13.55 will be 85.97. So let me just show that also by calculating, because so your phi is 28.64, take tan of that, and then that multiplied by 13 point, okay. Oh, I guess I don't have that. So I'll just calculate and then I'll just let. So your tan of 28.64 and tan of that 0.546. I'll write it down. 0.546 and tan of 13.45. 0.239. So 0.546 into 0.239, that is how much will it be? 0.13060, 0506, it's all the same. So cos inverse of this value will be okay, cos inverse, I'll just use my phone. Actually, you guys also parallelly solve with me, because that will be really helpful, and that is what is the motive of this session. Cos inverse of 0.546 into 0.239. Yeah, that is 97.50, and your omega st similarly will be 85.97. So does anybody have any doubt in this? Okay, so the day length or the sunshine hours, the way you calculate. I hope everybody is able to hear me. Yes? Oh, okay. Yeah, I just want. So your day length or the sunshine hours, that is when your sun sets and when your sun rises. So the duration of the sunshine hours, that is between the sunset and the sunrise, is Td is equal to, this is a formula that is again given in the lecture, 2 by 15 of omega s, this omega, the sunrise omega. So that is 97.50. So 2 by 15 of that 97.50 will be 13 hours. So that's a quite a long, that the reason why it is that is because it's somewhere close to your June 21st. So if you remember in that sun path diagram, where they have calculated from June 21st, for the June 21st, if you actually like calculate every single okay, for every single, if you see the sun path diagram, I'll just show. Okay, if you see the in the lecture, if you see the sun path diagram, you can actually see that it will be a curve for June 21st, and that will be having 21 splits, 15 splits. So the June 21st has the longest day. It has almost 15 hours of sunshine hours, whereas if you see December 21st, it will have approximately 8. So this August 16th is somewhere between these two, so it has 13 hours of day length, or probably the sunshine hours is 13 hours. So this is how you calculate. Td is equal to 2 by 15 of omega at sunrise, and that omega value should be in degrees. So 2 by 15 of 97.5. So 2 into 97 is 195, that divided by 15 will be 13 hours. Now here you need to calculate the local apparent time. So what is the local apparent time at a particular location? So that is standard time plus minus 4 of standard time longitude minus longitude of the location plus equation of time correction. So there is a correction factor which will come into picture, and that is evaluated using this using this equation 229.18, 0.00875 plus 0. It's a very big expression. Using this expression we calculate. So the B value is n minus 1 into 360 divided by 365. So your n here, can anybody tell me again what is the value of n? It's 228, August 16th. So as we calculated before here, 228. So that 228 is the same thing that you will apply here also. 228 minus 1 into 360 divided by 365, that will be your value of beta, B, which is 223.89. So that is what you are going to substitute in your equation of time correction. So if you substitute and then that calculate, what result you will be getting is minus 4.688 minutes. So yeah, everybody please let me know whether this value is correct. I'll just wait only 1 minute. So yeah, it is minus 4.688 minutes. So now you have to substitute in the equation. See, our standard time, what that solar time we had taken was 16 hours. I'm just going to mention the same as 16 hours minus 4 times standard time longitude. It's not the longitude of the location, that is separate. This is this one. IST longitude is 82 degree 30 minutes east. So we have to consider that here, the standard time longitude minus your longitude of the location. Oh, longitude of the location, that is 77.21 degrees. So you have to mention that here, plus minus 4.688. Now 16 hours minus 4 into this thing will give you 26 minutes. And here also you need to be very careful. It's not 1600 minus 26, because if you subtract 1600 minus 26 it will be 1574, but it is 1534, because it's the 16 hours is 4 p.m. 16 hours. So it has 13 hours 60 minutes. Out of that 60 minutes you subtract 20 minutes, so that is 15 hours 34 minutes, or 15 is to 34 hours. So this is a place which you have to be extremely careful, because here mistakes can happen, because it's 1600, so minus 26, so there are chances that people would say it is 1574, but here that 1600 is not 1600, it is 16 hours. So I hope everybody understood this point. If anybody have doubt, please let me know, because this is very important. That I cannot tell now, because I don't know how the question paper will be, like, phrased. So I either need to talk with both the professors before letting you know, or you could do one thing. You can actually give this as a query in the ask a question section. There is a, in the NPTEL, if you see, there is a place called ask a question in the where you can see that course recommendations and everything. There you have one subheading which is called as ask a question. Over there, if you give, they will reply you back. But for the time being, you have the formula with you right now, so do let me know if anybody has any doubt here. So which means I can move on. Okay, next we calculate here air mass. So in the question, if you see, I have specifically asked even for how do you calculate air mass. So air mass is 1 by cos theta z. If you see the expression over there also, it is clearly mentioned the air mass is equal to 1 by cos theta z. And yes, here what is theta z? Can anybody tell me what is theta z? I purposefully I didn't mention what is theta z here, like how to calculate. Anybody? Because somebody actually took this thing of everything of the angles. So what is theta z? And how do you calculate theta z? Yeah. So in this, so it's, yeah, it's correct, zenith angle, and you have to modify the angle of incidence accordingly. So what are the modifications that you will do for calculating the zenith angle? So okay, let's just keep that air mass here, because that zenith angle question was solved also for the next problem. When we move there, we will discuss that one, and then let us come back here. Now here this is a very important this thing, because here all we calculate only what is the local apparent time, what is the hour angle at sunrise or sunset, angle of incidence and everything. The reason why do we calculate all these things is basically to evaluate the monthly average daily global radiation and your monthly average hourly global radiation. So how much is your global radiation coming? That is what, how much amount of energy that you are able to receive that falls on the flat plate is a very important parameter, because that is what we are at the end going to take under consideration. It's not that the angles, these angles are just a prerequisite for calculating these things. So this is very important. So we need to really concentrate here. So here you have this Hg bar, H naught bar is equal to A plus B S bar slash S bar max. Your H naught is given as 24 into 3600 by pi, and that is a very big expression. So can anybody tell me what is this ISC means, or H naught means, or Hg bar means? And there is one interesting part here. I have specifically chosen August 16th. It's not like any other day. It's August 16th I have taken. And can anybody tell me why? So August 16th, for example, is one of the days which is, over there in that particular day, the H naught that you see here and then the H naught bar that I have written here will be the same. That is one of the extra terrestrial days where you have a similar pattern for that of the cloud cover. So these are the values that were previously evaluated for that particular day. August 16th they have particularly calculated, like every month they have a particular day. It's like for September it's September 15th, October is 17th I guess, and like that every month has a specific day in which they have calculated, and they have proved that HO and the HO bar will be same. So here we first calculate HO. So that's a very big expression. You have ISC. What is ISC? That is the solar constant, right? Yeah, which has a value 1367 watt per meter square. So here you have to actually convert this watt per meter square into kilojoule per meter square per day. So I guess, I mean, if you just bother only about this expression, then I guess probably everybody would be able to do, because 1 watt is 1 joule per second and 1 watt per meter square is joule per meter square second. So if you have to calculate it in day, then you need to actually just multiply that with 24 into 3600. The reason why this 24 into 3600 is because here it is in the sum of seconds, like 1.367 kilojoule per meter square second. Let me just write it also. 1.367 into 10 power 3 this is the value, and this expression is kilojoule per meter square, and that is in seconds. So for one day, wait, let me just see whether is it possible to open Jamboard. That will be more everybody can see the whiteboard, right? So I'll just write here. Your 1.36. Oh, this is more. Just let me go through PPT itself. So your one day has approximately 24 hours. Each hour will have your 3600 seconds. My PPT is visible, right, for everybody? Oh, okay, okay. Sorry, because I just thought that Jamboard will work, but it didn't work. So that is how this is calculated. So 24 into 3600. It's just the unit conversion, because we actually represent this HO, that is monthly average daily global radiation, in terms of kilojoule per meter square day. So here we calculate that way. So that is the reason we have this 24 into 3600. ISC is your solar constant. You have your n is basically the number of days, that is 228, and omega s is the hour angle at the sunrise, where the sun rays we consider are parallel to the horizontal surface. So omega s value is 97.5. Please don't confuse this omega s with the omega, that is the hour angle. That is the hour angle at a particular time. This is the hour angle at the sun rise. So at sunrise we know that omega here is 97.5 degrees. So that is what we have to use here. So apart from that, I guess phi is latitude and this is declination angle, and these are also, so you can actually calculate. It's a huge calculation, yeah, and you need to be very careful, because and here it's not in radians, it's in omega s. If you see this 2 pi omega s by 360, this omega s is in degrees. Specifically they have itself converted that it's actually in radians, but then here, since this pi by 360 is there, this was supposed to be in radians, but the formula itself has calculated it in degrees. So yeah, please be careful, and then I hope this value will come. I'll just give some time, and then, because this is a very big calculation, so, and let me just check whether I have to explain anything. And is there any doubt with this slide or previous slide? Anything? I forgot to mention, see here I have actually, if you guys actually see, I have given 30 seconds. So 30 by 60, which is 0.5. So 82 plus that 0.5 makes 82.5. So, and here you need to be very concerned with the units. And then if you just calculate this, the value that you will get for H naught, that is the monthly average global radiation, that H naught is 44,838.7399 kilojoule per meter square day. You can calculate, you will get this results or probably something very close to this. Now, as I told, this is an extraterrestrial day, this is a clear day. So in a clear day there will be no this thing for a cloud cover, there will be no signs of a cloud cover. So that particular contribution from the cloud cover will be neglected. So and HO and H naught will be equal to H naught bar. So that will be 44,838.7399. This clear day is specifically for every single month. Like for August it's on 16th, For June also it's on 16th. For September it is on 15th. You can see through the lecture. I guess lecture number 3 on problem solving, the dates are clearly given. So you can actually see it's August 15th, August 16th, September 15th, June 16th. So here I have specifically taken in such a way that I can correlate HO and HO naught. HO bar. So the thing is, if I take other day, I have to even include that cloud cover percentage. So that will make the calculations more difficult, and it is out of scope of this course. In this course, we only bother about these days. So with respect to that, we have to calculate. And here, so this is the formula, Hg bar by Ho bar is equal to A plus B times S bar by S max. Oh yeah, actually it's given in the lecture. It's for every month it is there, like for all the 12 months there is one particular day which is dedicated, which is for this particular, which is considered as a clear day, and the values have been calculated. For September it is September 15th, August is August 16th, and for June it is June 16th, and for April it is April 15th. Yeah. And you can actually see, if you see through the lecture number 3 in the week 1 video, you will get that. Ananda Lakshmi ma'am has specifically given the list of dates, so you can actually check that. That will be like you can actually have a note of that there. Yeah. And so here is the formula. Here the value of A and B matters. A is 0.25 and B is 0.57, but in the lecture if you see, the A value is around 0.3 and B value is around 0.4. The reason why there is a difference, this is a very important point to note down, and I think everybody, and I hope that everybody is noting down, and then if you are noting down, then just please put a important mark and then write this. This value of A and B varies with location. So what was solved in the video is for a location somewhere in Mumbai, I guess Pune or Nagpur. Here I am solving it for New Delhi. So that is the reason the values differ. A is 0.25 and B is 0.57. And if you want to really know for what are the different locations, this thing, what are the different locations and what are the values of A and B, then you can visit this paper, this law of J. Etel 1966. I have given the reference also. If possible, if you have time, then I will just anyway you will get the link to this PPT. So there I will give it as a link itself, so that will be easy for you guys. So A is 0.25 and B is 0.57 for New Delhi alone. For Pune it will be different, for Kolkata it will be different. These are all calculated values. These are all empirical relationships, so they have been developed and proposed by researchers after doing multiple experiments on the solar collection. So we have to take this as set, but I guess in exam if they ask this, they will be giving you the values of AB. So it's just that if you are going to design a solar flat plate collector, you should be having a understanding of these values or how to get these values. So if we calculate Hg by Hg naught with 0.25 and 0.57, yes, what are S bars and S bar max? S bar max is your maximum amount of the sunshine that you can get, that is the duration of your sunshine, the entire duration of your the length of the day. So that we actually calculated, Td is equal to 2 by 15 into omega, that is 97.5, so which is 13 hours, and your just that S bar in the numerator, this S bar is 9.2, which is given in the question. This is the average sunshine hours. So I will just mention that here. Yes, I will just write S, I will modify it later. 9.2 hours, your S max is 13 hours, which is calculated, this is the day length. or maximum sunshine hours. So that's how. So S bar is 9.2 and S bar max is 13. I'll just make this picture a bit bigger. So your Hg bar will be by H naught will be 0.653. Point 653. So this is the value. So A and B are empirical correlations. I mean the values which have been already proposed by researchers. So that is 0.25 and 0.57. If you substitute this here, you will get 0.653. And you know HO bar, which is 44838.739. If you multiply that with this, you will get 29,279.6971 kilojoule per meter square day. So this is your Hg, that is monthly average daily global radiation. You have to calculate Hd also. So that Hd is monthly average daily diffusive radiation. So the radiations that when it falls, whatever that gets diffused out of after striking the plane, that radiation is called diffusive radiation. So there we have three empirical relations again, which are proposed by different researchers: Modi et al., Garg and Garg et al., Gopinath and Solar et al. So these are empirical relationships, and so these values 1.411, if you see 1.696, 0.8677, 0.7365, all these values are predetermined, so they cannot be changed, and those values have to be taken as such. So here you have your Hg by H naught. You can substitute this here, and if you calculate, you will get Hd by Hg bar, and if you multiply your Hg bar, that 29279, into this, you will get 886.739. I'll just show the calculation. Okay. I hope everybody is able to follow, because this is quite, there are a lot of relations we have to follow. So in case if anybody don't understand, then just please let me know, because this is very important. Because we will be at the end, if you see, we will be comparing what is your beta value, how does your beta value will affect the global radiation, probably this week, if not possible next week. So please, in case if you are unable to understand, then please let me know. 1.696 into 0.653 into 0.653 into plus 1.411 into 29279.6971, 88886.739. So this is how we calculate. And your Garg and Garg et al., the formula is same. So here, instead of that Hg by H naught, you have S bar by S max. As I said, S bar is your average sunshine hours, and S bar max is your the day length, the maximum amount of sunshine that you can get on that day, August 16. So that is probably 13 hours as we calculated. So if you substitute, then you get this value, 10,142.487 kilojoule per meter square day. Similarly is for Gopinath and Solar et al. sorry, this value I thought it would be visible, but so this, if you calculate, you will get this. If you see here, there are two values which are matching, and there is one value which is not matching. So yeah, because one thing is there in 8886, another thing is there in 8000, sorry, 368. So these values are not matching. These values are kind of same, but if you see for Garg and Garg Eaton empirical relationship, it is 10,142.487. So that is not matching. So yeah, so the reason why is because everything is an empirical relationship. Every researcher, when they have proposed these relationships on the basis of the observations that they have got. So it's not always necessary that among all the three relationships, every single the way of calculation will have the same value. It differs. If you see in the lecture of a similar problem which was solved by Anandashmi ma'am, she had the value of the HD bar, that is the monthly average hour daily diffusive radiation, for which was predicted by Modi et al. And Gopinath and Garg and Garg et al. Was same. But whereas in case of Gopinath and Solar et al. It was different. So these values, because since it's an empirical relationship, we cannot do much, it's just predicted. So we have to calculate through all the three empirical relation and then check which are matching or which are not matching. So here these two values are matching, that is by the relationship proposed by Modi et al. And Gopinath and Solar et al. So I just go with the Modi et al. Value, 8886.739 kilojoule per meter square day. So this is again another one. This is about daily, monthly average daily global radiation. So you receive the daily global radiation, you take the monthly average of that. But what about the hourly radiation? That is at every this hour, and you average that to that month. How much is that value? So that also has to be calculated. So the formula is Ig bar by Hg bar equals I naught bar by Ho into A plus B cos omega Fc. So here there are a lot of different terms, A, B, Fc, and if anybody has gone through, I hope you guys have went through the lecture, you will be able to say Fc is tilt factor. So that is usually calculated by this expression, A plus 0.5 B omega s minus sin omega s cos omega s divided by sin omega s minus omega s cos s, or cos omega s. Omega s is your, what is that called? It is the sunrise hour angle, that is we calculated around 97.5. So here you have again the I naught, what is the incident radiation? So that will be ISC into 3600 and similar relationship. So here if you see the value of A and B, you have to calculate the value of A and B, and these are given by these two expressions. It's a standard expression. A value is 0.409 plus 0.5016 sin omega s minus 60, and B value is 0.6609 and omega s minus 60. Omega s is, as I said, it's the sunrise hour angle, 97.5. Similar here. So A and B value you calculate. Fc is your tilt factor. Here if you see this omega s you need to calculate in radians, it's not in degrees. So 97.5, when you convert to radians, it will be 1.7, like 97.5 into pi divided by 180. Pi value is 3.14 divided. Yeah. 1.700. So that is 1.7 radians. That's what even here also it's written. Sorry. 1.7 radians. And then the rest other omega s is in angles. So please be careful. This omega s, which is separately out of without the sine and cos, those angles, that omega s is 1.7. So if you calculate this 0.5, B value is 0.3707, A value is 0.714, and then if you calculate the value of FC, that is your tilt factor, will be 0.993. You know A, you know B, you know FC. These two are relationships which is like predetermined, so we just substitute the value of that the hour angle at sunrise, and then we calculate. So we calculate the value of I naught, that is what is the radiation that is incident onto the tilt surface, is ISC into 3600 plus the same formula, this one, 0.033 cos 360 n by 365, and this sine phi sine delta plus cos phi cos delta and cos omega. So you need to substitute here omega. This omega is not your hour, what do you say, the sunrise hour angle or sunset hour angle. This is the hour angle that we calculated for 16 hours. If everybody remember the value, this value was minus 60. So please take a note of this, because you have three different types of hour angle: omega, omega s, omega st. Omega s is your hour angle that is calculated at that particular standard solar time, that is 16 hours. Omega s is what is calculated at sunrise. Omega st is what is calculated at sunset. So if you multiply all these, and again cos of minus 60 is plus 0.5 and n is 228. So if you multiply, and then if you get I naught will be 2580.845 kilojoule per meter square hour. Here for that I naught, that is your monthly average hourly global radiation, we keep it in meter square per hour, because it's a hourly global radiation, so it is calculated for 1 hour, whereas that case H, if you see, that is daily global radiation, so that's the reason we calculate it for day. So the units make sense here. Our daily, so it is like 30 days, so it's a day. So for a month you have 30 days, so that is that. So you actually calculate that global radiation per day, that is represented in H. I is the monthly global monthly average, but hourly global radiation. So it's like you calculate the global radiation per hour and then take that average, like for each hour you calculate for the entire month, and then you take that average. That is given in terms of hours. So you calculate Ig bar, that is monthly average hourly global radiation. ID bar, this ID bar is monthly average hourly diffusive radiation. So if you calculate Ig bar using this formula, you know HO bar, that is HO, the 4838.7399, and you know Hg bar, that is 29279.6971, and if you substitute that value, you know IO and you know HO bar, that is, as I said, 44838.7399, and you have A is 0.714, you have B 0.3707, you have cos omega, that omega is the hour angle, cos of minus 60 again, cos of minus 60 again is plus cos of 60, divided by your FC, that is the tilt factor which we calculated, 0.993. So if you multiply and do, and then take this here, and then if you do the mathematical operations, you get 1526.326 kilojoule per meter square hour. It's calculated in hours. Now we calculate for the hourly diffusive radiation, that is ID bar. So here the formula is ID by HD is I naught by H naught by A plus B cos phi. Here you have to, again it's similar, A and B, But for Ig bar, you have the value, you have the expression, straightforward expression. But in case of a diffusive radiation, you have empirical relation again. You need to know your Hd bar by Hg bar value, and here if you calculate, Hd bar is um, 8886.739 and your Hg bar is 29279.6971. So let's calculate. 8886.39 divided by 29279.6971. It's around 0.3. Yeah, it's around 0.3. So the value, so your Hd by Hg bar, if you accurately calculate, it is around 0.3. I guess here it comes 0.2858. Mathematical, like I have just written 886, I believe 8886, I didn't include the decimal. So if you calculate it properly, you will get 0.2858. That is holding with the first expression. So if you calculate, if you substitute that Hd by Hg bar, that is 0.2858, and then if you calculate the value of A, it will be 1.4369. B, again this is the expression. These are all previously determined and supplied equations. So we are just using this, substituting it, and then we are going to analyze. So here again omega s, you need to take it in radians. So if you calculate, your B value will be minus 0.579. So I guess since we know I naught, we know H naught, A, B, omega is minus 60, Hd bar is known. I want others also to calculate the Id bar and let me know the value. So people can let me know the value of Id bar. I'll wait for 2-3 minutes because these are quite important. It's simple, you just need to substitute Hd bar, or I'll just write that as well. So let me move this here, and then let me just write what are the values, so that it just you know A value, that is 1.4369, B value is known, 579. You have your I naught, which is the value of I naught, 1526.326, and you have your H naught, which is 44838.7399. You have your Hd bar, I'll just write Hd, which is 886.639. Omega is minus 60. W, I'm just putting W here, but it is omega. So you have all these values. So you just need to substitute and let me know what will be Id bar. So if you calculate, your Id bar will be around 552.652 kilojoule per meter square per hour. If you calculate. The value would be id bar is equal to 552.652 kilojoule per meter square hour. Here the units will be the same because the HD and then the HO, those units will get cancelled, so it's just your hours, so you don't need to bother about units in this case. So yeah, we move on now. Now we basically come to solar radiation on tilted surface. So how much is the amount of radiation that falls on your surface, that IBN, that is the intensity of the beam radiation, the global radiation, and then the diffusivity radiation, those three parameters, the intensity. Till now we just calculated the monthly average, daily average, but what is the total amount of intensity that falls on? So for that we need to use this. So yeah, here somebody said, I asked previously the theta z, which is the same as that of the zenith angle. So in case of zenith angle, it is that the your beta value will be actually equal to 0, because in zenith we assume that the surface is along the horizontal direction. So the tilt, the beta that you get will be equal to 0. So, so if you go to the main expression here, and if you substitute the value of gamma equal to 0 and beta equal to 0, I'll just show in the next expression we have. So cos beta will be, so since beta is 0, cos this beta will be 1, sin beta will go off, sin beta will go off, sin beta will go off. So you will have only the expression that is, I haven't written. Okay, I'll just let us write that. Or I can write. So your cos of theta z will be that will here it is. Cos of theta z will be sin phi sin delta plus cos phi cos delta cos omega. Like here in the angle of incidence expression, you mentioned that we mentioned that beta equal to 0 and gamma equals 0. That is because the flat plate is pointing south, and then the beta is 0 is because we want to find the zenith angle. Zenith angle is the angle between the horizontal, the normal to the horizontal surface, and then your sunlight beam. So if you calculate that, here that is what is calculated. So sine of 28.64, sine of 13.54 plus cos of 28.64, cos of 13.54 plus cos of 45. So cos theta z will be 0.715. So IBN value is calculated using this expression, a e power minus b cos theta z. The value of a, b and c, I'll mention it here, I'll write it here. A is 1107 watt per meter square. These values actually have been taken from the reference paper, this reference, same reference here, this LOF APETEL. I'll just give the link also in the updated PPT, exactly the link, so that you can just, if you click, you can, so that you can directly your PPT will redirect you to the paper link. And then your B value is 0.201 and then your C value is 0.122. These are determined value for the month of August. If you check that paper, for each and every different month, these values will differ. Not very much, but yes, there will be some difference will be there. If you see even in the lecture or the course, the week 3, the week 1, but then the third lecture, the values of A, B and C over there were different because that was calculated for the month of April. So the values of A, B and C will differ every month. Here we have taken August, so the value of A and B and C are 1107, B is 0.201, C is 0.122. So if you substitute all this and calculate, you get IBN, that is the beam normal, 3008.58. ID will be this. IB will be IBN cos theta z, which will be 2151.13. And IG, that is your entire, both the global one is the beam one plus the D, that is beam plus the diffusive is the global. So that will be 2518.176 kilojoule per meter square hour. Now those are the global beam and then the diffusive radiation that falls on the surface. But what about the IT, that is the total radiation that falls on the tilted surface? Here it is on a horizontal surface because we have assumed theta z. So this is not something that is tilted, this is for a plane surface. So we calculate it for tilted surface. So here the formula will be IT bar equals IB bar RB bar plus ID bar RD bar, and then RR bar IB bar plus ID bar. RB bar is the coefficient for the beam radiation, coefficient for the diffusive radiation, coefficient for the reflective radiation. That is, when the sun radiation fall on the surface, some of the radiations will be reflected. So that is that particular value. So that is, for that we need to incorporate the amount of reflected radiation. So that is the reason we use RR. So RD bar is RD bar value is 0.853. It is calculated using the expression it is calculated using the expression 1 plus cos beta by 2. RD is 1 plus cos beta by 2, and your RR is rho into 1 minus cos beta by 2. Your rho is the reflective coefficient, so the rho value will be different. So for, if you see, for rho value is 0.2 for normal ground, whereas the value will be different for your snow covered ground. For snow covered ground, P will be 0.6. But since in New Delhi we do not have any chances of snowfall, probably in the in other like northern parts like Jammu and Kashmir it is possible, but since here we take specifically the condition of New Delhi, over there we will not have any snowfall. So it will be on every day on August 16th, New Delhi will be having a normal ground. So there will not be any snowfall. So the p value is 0.2. So if you calculate using this expression, here beta is the slope, that is 45 degrees. So if you calculate with this expression, your value of RD, RR and RB bar will be 0.853, 0.03 and 0.560. IT bar is calculated using this. You know IB bar. RB bar is cos theta I by cos theta z. This is the expression. RR bar, you know. IB bar is calculated like IB bar is equal to IG minus ID. So if you have, you know IG, you know ID, so you can calculate IB. So that value is around 500 and 552.652, and the rest of the value is just calculation. HD bar is again, you need to same way you need to calculate. So if you calculate, let's calculate. So HT will be equal to, this is the total amount of the incident radiation on the tilted surface. So your RB is 0.560 into your HB will be HG minus HD. HG is 29279.61 minus your HD will be 8886.639 plus your ID bar. Your ID bar is 8886.639 into your RD bar. RD bar is 0.853 plus your RR bar. RR bar is 0.03. You calculate using this expression, that is 0.2 into 1 minus cos 45, that is 1 by 1 root 2, that will be around point, I'll just write that way, 1.4, 1.414. This entire divided by 2. So that value will be around 0.03. So here you need to just calculate, and then IB bar plus ID. So this 29279.61 plus minus 8886.639 plus your ID. ID is again 8886.639. So it's the same specifically. It's just that it gets cancelled. So your HT, final HT will be final HT will be 36070.83 kilojoule per meter square hour. This is the value of HT, this is the value of IT. So these are the total amount of the radiation, the monthly average, the total solar radiation that is incident on the surface, the value of HT and IT. So does anybody have any doubt? So because this is the end of the question number 1, so does anybody have any other, like in this total PPT, do you have any doubts, or where you cannot actually understand, then please do let me know now. Yeah, 1 minute. Just a second. So you are able to see my slide. I'll just Anyway, this slide will be available to you within a very short span of time. Probably by this week, the NPTEL team will email you this link to the PPT. So you can actually go and do let me know, like in case if there is any mistakes, because this is a very tedious calculation, as you see. So there can be chances of making mistakes. So do let me know in that case as well. So are there any queries? So I do see that there are few questions that has come up in the chat box. So I mean, sorry that I couldn't really tell the could really see this one. So there is one question which says, why we say biomass as a green energy, it causes pollution. So the thing is, uh, it undergoes a carbon neutral cycle, if you see, because you take up the carbon dioxide, the plants take up carbon dioxide, they use it, and then when you burn them, the similar amount of carbon dioxide or a very less amount of carbon dioxide compared to that is goes to the atmosphere. So what is consumed also goes back. So that entire, if you see, what comes in goes out. So there is uh, no any kind of pollutants that is actually released. Whatever this thing has happened, whatever the amount of carbon dioxide that is taken in goes back to the atmosphere, forming a carbon neutral cycle. So because of that, we say biomass as a green energy. Now green energy, we can say that it is a renewable energy because we do get it from plants. So yes, but again the carbon neutrality concept does exist. Whatever the amount of carbon dioxide the plant takes in, that is what is going to get burnt at the end. In fact, to be honest, lesser than that will be taken out from them when you burn it. So the carbon neutrality cycle, the carbon neutrality in the atmosphere is maintained. And can you show, so I'm sorry, I mean I couldn't show the slide previously, Soham. And yes, the recording of this video will be available. Yes, like in case if you have any queries, you can always post it in ask a question tab in the NPTEL lecture. If you see there, you will be able to get answers for all your questions. Like there were some of the questions about the exam, so that also you can get it clarified there. And also it's not just about the exam questions, it's also about the technical questions. If you have, then either me or the course instructors themselves, or probably the other TAs who might also can help you out there. So in case if you have any doubt on any of the lectures or the PPTs or probably this live interaction session that is happening, please write it there so that it will be visible and also helpful for others. This recording will be available. You will be getting the link for both the recording as well as the PowerPoint presentation. If you see, I had actually planned for 3 questions, but unfortunately due to time constraints we can only keep for 1 question. So either what you can do is you can actually solve this question in your free time. This question number 2, it's similar, it's the same question, but only the difference what is there in that question is, here I have said that the flat plate collector is installed on the ground surface, it's on the horizontal direction. So beta value what you see is 0 degrees. So so you can actually compare how does the slope of your flat plate collector affects the performance. This will be a critical parameter because you need to optimize the angle for the to harness maximum amount of the solar energy. This is a very this beta value will play a very important role. So that is what is this question. Either you can take this question and then you can solve it back. We will discuss this same question, we will start from here next week, next Sunday, the same time 5 to 7, and then I can really tell what is exactly how does the value of beta affects your solar radiation, and then we can progress. So yeah, that might be fine. I will take up from that point next week. So if you have any more questions, you can always put it in your chat box now. Do you have any questions anywhere if you haven't understood any particular concept or any particular calculations or something that what I have said, then you can raise your questions, or you can also put it in the chat box. let me stop presenting. So does anybody have any questions, or like, shall we conclude the session for this week? Yes, this class recording is will be available. uh, yeah. Oh yeah, the class recording will be actually like sent to you by the NPTEL team, or it will be sent to you by the NPTEL team. Or in case if you guys did not receive any notification, then I'll tell you probably within this week or the next week. I will get a clarity on that, because this is the way we are going to conduct it for the next 11 weeks that we have, because it is a 12-week course, so we have 11 weeks. So that is how we are going to conduct. So every week I will be here, and then at that time I will let you know how the class recording will happen. I mean, you should receive it within this week, but in case if you don't receive, then towards starting of the next live interaction session, that will be probably on I guess 3rd, today is 28th, 4th February. So at that time I will let you know about the recordings. So I will stop the session for this week. So I thank everybody who have joined, like who have taken their time and then have really joined this session. I hope this session would have been helpful for you. And yes, the recordings and the link to the presentation will be available very soon. So as the final step, I also like to thank the NPTEL team and professors, the course instructors, Professors Anand Lakshmi ma'am and Vaibhav Vishant God sir, for giving me this opportunity to interact with you all in through this live session. So yes, I guess that's all for today, and we will meet on 4th February, same time 5 to 7, with similar kind of problems for the next week lecture on solar collectors. So yeah, thank you, and